So we're looking at the Math 2 Chapter 7 review. This is focusing on right triangles and trig. Number 1, we have the lengths of two legs of a right triangle are 4 and 7. We need to find the length of the hypotenuse. Whenever we're looking at just sides and no angles involved, it's going to be a Pythagorean theorem. We'll go 4 squared plus 7 squared equals x squared because the hypotenuse is by itself. I get 16 plus 49 equals x squared. That is 65 equals x squared, or x is the square root of 65. Now 65 is 13 times 5. It's not going to simplify any further, so we're going to go with square root of 65, which was d. For number 2, we have, again, the legs are now 2 root 3 and 5, and we need to find the hypotenuse. So x squared equals 2 root 3 squared plus 5 squared. 5 squared is 25. We'll take care of that one. But 2 root 3 squared, we square the 2, which makes it 4. You square the root 3, and that just becomes 3. So this becomes 12 plus 25, or x squared equals 37. And x is the square root of 37, which is a. For number 3, we have one leg is 4 root 6. Hypotenuse is 11. We need to find the other leg. We're going to go 11 squared equals 4 root 6 squared plus x squared. Because our unknown is a leg, the hypotenuse is 11 squared. It needs to be by itself. That's going to be 121. Now, 4 root 6 is 16 times 6, which is 96. So I have 121 equals 96 plus x squared. And this is 25, after I subtract, equals x squared, so x is 5. For number 4, we have a baseball diamond is a square, 90 feet on each side. We need the direct distance from home plate to second base. Now this, at first, almost looks like a Pythagorean theorem problem, which it would work for it. But since this is a 45, 45, 90 triangle, you can actually use your 45, 45, 90 rule, which says from the leg to hypotenuse, we multiply by root 2, and it comes out to be 90 root 2. It's better to know the 45, 45, 90 rule instead of having to rely on Pythagorean theorem here. And most of the special right triangle problems, you got to know the rule. Pythagorean theorem won't work. Number 5, we have a rocket is launched. Now, these can easily become trig problems if we're asked for angles. If we look, I have the distance from the site and the height's 36, so it is Pythagorean theorem. X squared equals 48 squared plus 36 squared. We get 2304 is 48 squared. 36 squared is 1296. We combine those. It comes out to be 3600, square root of that is 60. Our answer is C. For number 6, we have a special right triangle. This is a 45, 45, 90. When I see 45, 45, 90, I think root 2. So I have hypotenuse, I want leg, I want something smaller. So to get smaller, I have to divide by root 2. Those reduce, and I'm left with 3. My answer is 3. For 7, we have the height of the triangle. Well, we want to find the height. We know AB is 16, BC is 17. This cuts down to just be a right triangle where we have 8, 17, and H. This turns into Pythagorean theorem. 17 squared is 289. 8 squared is 64, so we'll subtract 64 there. We get 225 equals h squared. Square root of 225 is 15. Our answer is D. Number 8, we have a special right triangle, or 30, 60, 90. At the hypotenuse, 30, 60, 90 revolves around the short leg. So I got to work through the short leg to eventually get to y. So 6 to x. Now for 30, 60, 90, I think of 2 and I think of root 3. So I either multiply or divide with 2 and multiply or divide with root 3. The leg and the hypotenuse, short leg hypotenuse, are connected by 2. It's because it's double the leg to get the hypotenuse. So I'm going to take half of 6 to get 3. So x is 3. I got that, which actually looks like C's promising answer. Now root 3 is the connection between short leg, long leg. I want to make it bigger, so I multiply 3 by root 3. So my answer is C. X is 3, Y is 3, root 3. For number 9, I start at the long leg. Now the long leg here, I have to get to the short leg by dividing by root 3. This, to simplify, I multiply the top and the bottom by root 3, and I get 40 root 3 over 3. So that's short leg. Now to get to hypotenuse, it involves 2. I'm going to double it. So multiply that by 2, really 2 over 1. And this becomes 80 root 3 over 3. I didn't change the root 3, I just changed the 40 times 2. So 80 root 3 over 3 is my answer. It's reduced, it's simplified. We go with B. Number 10 requires us to rearrange that equation just to figure out which one matches. Now, in the ones we've talked about in class, whenever we come to this problem to solve, we always want to multiply the denominator over first. I get 17 times cosine A equals X, which would be answer C. You're not going to move the A inside, or the 17 inside. It doesn't become a fraction, because you just multiply over denominator, and you're good. Now, if they were flipped, if it was cosine A equals 17 over X, you would still multiply over the denominator. That wouldn't be finished, so then we divide over cosine A, and it would come out to this. Not the same problem, though. That's separate. It's the other type we see with our trig ratios. Number 11 is a trig problem. It requires an angle, so Pythagorean Theorem is out. It requires a leg, or a side, we should say, so it's going to be a trig ratio, and it's not a 30, 45, or a 60-degree angle, which excludes the special right triangles. So it's going to be a cosine, because it's adjacent and hypotenuse, and you should have this written somewhere on your paper, so you have that as that quick reference to what you're using. I'm going to go cosine 25 equals 3 over x, multiply over the denominator, then divide back cosine 25. So now I'm going to go 3 divided by cosine 25 gives us about 3.3 to the nearest tenth. If you're not sure on how to use your calculator, I put a video up for that. I would check that out because that shows you how to do your trig ratios in your calculator, depending which calculator you have. I tried to cover the ones we have. 12. Right triangles DEF. DE is 15. We have 36 and 39. We got to make sure we can put things in the right place. So cosine F, that means F is not a right angle. DF is the biggest side, so that's got to be 39, which means D ends there. So E is where the right angle is. And that's an important thing to pay attention to as we set it up. DE would then be 15, EF is 36. So we want cosine of F. Cosine is adjacent over hypotenuse, 36 over 39. We look, that's not there, but we didn't reduce our fraction. We can divide them both by 3, and it becomes B12 over 13. We want to answer B. For number 13, we have an 80-foot support wire, so that's 80 feet on the hypotenuse. It's attached to the top of the tower, and our angle is 70 degrees. How tall is the tower? An important thing for the word problems is get to that labeled correct triangle. So now I'm here. I'm going to go a sine of 70 equals x over 80. Multiply over the 80. So I now have 80 times sine 70. And I get that x is about 75.2, which would be 75 feet. Number 14. Ladder is leaning against a tree, hits the tree at a point 15 feet above the ground. There's my vertical distance. The ladder is at a 62-degree angle. How far is the bottom of the ladder from the base of the tree? So we don't want to know the length of the ladder. We take the height and figure out the distance it is away. This is going to be a tangent problem because it does not use hypotenuse of 15 over x. Multiply over denominator. Divide tangent back. So 15 divided by tangent 62 gives me that I have x is approximately, to the nearest tenth, I got 7.97. That looks like 8.0. Answer D. for number 15, we need to figure out how we'd set up for cosine of p. So they didn't give us numbers, we're just going to use letters. Cosine of p is adjacent over hypotenuse, so that'd be E over F. We go with B. And then keep in mind, as you're getting ready for your test, you will have some questions that are as basic as this, just understanding the correct ratio. You also have the ones where maybe they give you a list and some of them are right, some of them are wrong. You'll have to work through them. But there will be some as basic as that. 16, I'm going to draw in my triangle. Angle of depression is 39 degrees. And then top of a 20-foot lighthouse, okay? What's the closest distance from the boat to the lighthouse? Now, 39 is the angle down. A big determination, if you're going to get this problem right or wrong, is whether you put the 39 here or the 39 here. Angle of depression is down from the horizon, which also means we put it in the triangle on the bottom corner, because the angle of depression is the same as the angle of elevation. So in this problem, I now get tangent of 39, this one here, is opposite over adjacent. So x times tangent 39 equals 20. Divide tangent 39 back over. So now it's 20 divided by tangent 39. This comes out to be about 24.69, so it's like 24.7. We're going to say that's close enough for C. Now, what you have to be careful with is the way this problem is easily mixed up. So this is the correct answer. We got that. The wrong way to do this problem. If you put 39 here, you would then have tangent 39 equals x over 20, because now the opposite is x and the adjacent is 20. And then you do tangent 39 times 20. And I'm only showing you this because I want you to see the difference. Now we get about 16.1, 16.2 when we round. Why that's important? That's the wrong answer. But it's there, because it's going to catch us if we get that setup wrong. Once you get to this, it's not difficult. You can solve through these problems, but it's picking that setup, paying attention to the word problem. So we're careful, we read the question, pay attention to our angle of elevation, angle of depression, get them set up correct, we're going to be good. 17, angle of elevation to the flagpole, we have 35 degrees. We need to find the distance away. Looks like tangent of 35 equals 60 over x. X times tangent 35 equals 60. X equals 60 over tangent 35. And I have, it's about 85.68. We'll call it 85.7 and go with A. Number 18, which expression can we use to find the value of x? Again, it's a setup problem. I have opposite and hypotenuse, so that'll be sine of 50 equals x over 3. If I look, that's none of my answers, so I can rearrange it. I'm going to multiply over 3 times sine 50 equals x. Now it looks good. We go with D. These are fractions. It's not a fraction in this case, because when we multiply denominator, we're good. C is wrong because they put the 3 and the 50 together. You do not do that. We didn't do that in class. You're not magically going to suddenly do that as you work through the problems getting ready for the test. 19. Which ones can represent the side lengths of a right triangle? This is testing Pythagorean Theorem. The converse, if the largest side squared is equal to the sum of the other two sides squared, it's a right triangle. If not, it's done. So we can kind of do them quick. I got 121 is 11 squared. Is that equal to 25 plus 100, which is 5 and 10? Nope. So that one's a no. Square root of 34. When you square that, it becomes 34. That is my longest side because it's also bigger than 25 and 9. Now I get 34 and 34. It's equal, so that's a yes. C, I get 64 equal to 49 plus 9. 64 is not equal to 58. That is a no. Next one, we go 144. Is that equal to 121 plus 25? That's 146, so that is a no. Square root of 10. Careful with this. You square it, it becomes 10. That is not your longest side. 64 is actually your longest side, or 8 is your longest side. Then I go 36 plus 10. This is a no because I have 64 and 46. Last one, 9 is your longest, so we go 81. Is that equal to 25 plus 49? That looks like 73 and 81. That is a no as well. That is Pythagorean Theorem converse. It's got to be equal. Longest side squared by itself, and go from there. Number 20, we're going to go setup. Look here, I got opposite and a hypotenuse. So we're going to go sine of 50 equals x over 200, which is here. Let's also, though, realize this could be 40 degrees because it's 50 and 40. I could also have done cosine of 40 equals x over 200. Now, although it's not the same answer, it's important to pay attention that the other angle can be found, and you may have to do that one. Last one is kind of some fun with special right triangles, trying to work through. You have your 45, 45, 90 first. I want to go to the hypotenuse of just this triangle, and this becomes 10 root 2. Then to get to x, I'm at hypotenuse of my 30, 60, 90, and I want to get to long leg. Well, I got to go to the short one first. So to do that, I divide by 2. So this becomes 5 root 2, and then I multiply by root 3. So this becomes 5 root 2 times root 3, which can seem difficult, but really you just put the numbers inside the radical together, and it becomes 5 root 6 is our long leg.